do anything for her illness. This was in the days before advanced brain imaging. This was in the days before Aricept. And the impression that I got, that I could perceive even at that time from her doctors, was that she has dementia, there's nothing we can do, and that was the end of it. But it wasn't the end of her suffering. And for 3 years in living with us, I watched her day by day decline even more, to the point where my final memory of her is still in the hospital bed with a lot of aggressive medical care, which didn't help her and made her at a level where she had to die a death that I knew that nobody should have to go through. And I've seen that scene replayed throughout my medical training time and again as people who are in their elderly and supposedly golden years have to suffer through the ravages of Alzheimer's and dementia. And it was based upon those experiences that I decided to dedicate my life and my research towards understanding how we can improve the brain and give it the most strength possible so that we can live our final years with the most happiness and the best health possible. And so to do that, to get at that level, I knew I had to train hard and train for a long time. So I studied hard. I went to the University of Pittsburgh and did the combined MD-PhD program, which is a special type of program that allows physicians to do independent research at a level that can be useful to the field of science and to the public in general. And then after that, I trained in my internship program and decided that the best place for me to be would be at an area that is a pioneer in brain imaging and science, and that's at UCLA Medical Center. But my ultimate goal in life, the future that I want to build for myself and others, is to change our world one brain at a time. And I'm so fortunate that I have somebody like Daniel Lehtman to be a partner in that goal. So the advantage of having both an MD and a PhD is that you can approach problems and questions from two perspectives. A physician diagnoses and treats patients, and they use all of the knowledge available to them to help patients one at a time. And that's very gratifying because you can see the immediate effects of what you do. A scientist takes a broader approach. They try to study an overall field and pinpoint specific areas that they can change the field. And in doing so, they develop a very specific and focused knowledge base that they can use to potentially help many more individuals than they could ever see in person. But you don't have to have a PhD to necessarily do that. One of the things that's always impressed me about Daniel is that he not only runs a very successful and widespread private practice, but he uses his knowledge and he uses his expertise to educate the public and broaden his influence beyond just the patients that he can see one-on-one. And so right here we see the timeline of training where you have to take basically close to a decade to complete the program. And what did I learn from that experience? What are the results of my research over those years? Well, there are several points that I want to share with you today. And the first point is that obesity, being overweight, is bad for your brain. But there are things you can do to improve your brain, such as physical activity and dietary choices. Specifically, I'll be talking about the dietary consumption of fish and all of the research I've done in this area. And the sum total of the research I've done over the years has shown that brain aging is optional. You have the power to change how your brain ages to the point where it doesn't even have to age as much as you think or even at all. And that's a powerful idea that I hope you can take away from today's talk. So this is William Mullen. He was an American artist living in London, and he discovered in 1995 that he was diagnosed with Alzheimer's dementia. And so what he started to do after he learned of his diagnosis is that he started to paint a series of self-portraits of himself as the disease ravaged his brain. And so what we see here is this first painting from the 60s And then we see a painting from 1996 on the top row. And as you can see, as the years go by from 1996 to 1997 to 2000, the brain ravages his ability to do what he had spent his entire life perfecting, which was his paintings. And so as a result, at the end, he couldn't even paint a basic self-portrait of himself. So as a result, we see that Alzheimer's destroys the brain and destroys the ability of people to be who they are. And that's something that I want to talk about in terms of how we can prevent that. So in talking about the brain, we see that there are various technical difficulties. The brain can give you, okay. Can everybody hear me? Okay. The microphone isn't really working, but I have a very loud voice. I think it's, okay. Okay, perfect. Very good. My loud voice is genetic, so I hope that can be beneficial to getting the message out. So there are certain areas of the brain that function in cognition, and Daniel has talked to you a lot about them. There's the frontal lobe, which is very important in intelligence, judgment, and behavior. And that's outlined here in red on this cartoon of the brain. There's the green part of your brain that we see here colored in. That's the temporal lobe, which is responsible for memory and learning. The purple part of your brain that we see colored here intersects with the temporal and parietal lobes, and that's important for language. And these are all things that help you be the best in terms of your cognition as you get older. And these are the areas that degrade in Alzheimer's disease. So in talking about Alzheimer's disease, I take a different approach than Daniel. Daniel looks at function. He uses SPECT to basically understand the leading indicator of the brain, which is function and blood flow. I look at the later effects on the brain, which affect the structure of the brain, so the actual physical matter that comprises the brain. And so we have gray matter in the brain, which houses all of our neurons, our brain cells that communicate through neurotransmitters. We have white matter tracts, which project like telephone cables and wires to different parts of the brain that allow the different neurons to talk to each other and integrate functions. And when the actual physical size of the brain and brain structure is affected, when neurons are actually dying and shrinking as a result of a process like Alzheimer's disease, we call that brain atrophy. And brain atrophy can be seen in this cartoon showing a normal healthy brain right here. So we have these coronal sections of the brain which kind of slice your brain in a certain plane. And we can see on one side a healthy brain that has full gray matter and white matter. But then on the other side we see advanced Alzheimer's disease where you see a shrunken brain, and that corresponds to so much brain atrophy that neurons have actually died off. And this is the process we're trying to avoid, because once you lose neurons, you can never regain them. And so your brain is the most precious organ you have because it houses all of your memories. It allows you to be who you are in terms of your personality, and it's irreplaceable. So who here wants to protect their brain? Well, I'm going to show you just how to do that based on my research. Here again we see a normal brain and we see an Alzheimer's brain. Look at all the dilated parts of the brain that correspond to atrophy. Again, this is what we want to avoid as we get older. So what makes brain aging optional? Some people say it's your genes that you inherit, but in my research it can also be the size of your genes and how much you weigh, unfortunately. How much you walk and exercise and are physically active can also influence how your brain does. And what you eat. You know, as Daniel has talked about, food can have a more powerful effect on your brain than any pharmaceutical, because you're consuming food at least 3 times a day for pretty much most days of your life. And you have control over all of these choices. And it's that control you have over those choices that makes brain aging optional. So the study that I'm going to be talking about, where we derive all of our data, is called the Cardiovascular Health Study. It was a study that was started back in the late 1980s to understand the effects of cardiovascular disease and later on brain aging in a cohort from the community. And the reason I talk about from the community is that you'll hear a lot of studies coming out from universities and clinics and different populations that can be a very narrow pre-selected group. But when you go into the community, you're able to draw conclusions that you can generalize to the overall population. And we had over 1,000 subjects that we followed in this study for over 20 years, obtaining information on dietary choices, their weight, their different cardiovascular biomarkers, and we also scanned their brains. So in the late 80s, we started this study, and then 10 years later, we scanned their brains, and then after that, we looked at whether or not these individuals developed Alzheimer's and dementia. The mean age of our study was 71 at the beginning, and we followed them out into their mid to late 80s. And we didn't just study Alzheimer's disease. We studied a precursor component to it called mild cognitive impairment. So how many here know someone who's had a senior moment? I'm not going to ask how many people have had senior moments themselves, and I might have to raise my hand because even though I'm in my 30s, I might have had a couple of senior moments already. So with all the things we try to understand in Alzheimer's disease, we look at the accumulation of senior moments to the point where people are so worried about them that they'll come to see a doctor. And at that point, we can use different tests to identify mild cognitive impairment. And what we now understand it to be is the early form of Alzheimer's that hasn't become so bad yet, but that is a high-risk state for later developing the disease. So we studied both of these things in our patient population. And when we look at the brain in these studies, we look at structure. We look at magnetic resonance imaging, which is a type of brain study that uses the magnetization of hydrogen. Remember, as Daniel said, the vast majority of your body is water. So if you can use